In 1965, two astronauts orbiting Earth looked down at the Sahara Desert and saw something that made them question what they were looking at. Not a storm, not a geological anomaly they'd been briefed on. Something that had no immediate explanation. A perfect, enormous eye staring back at them from the sand. That image has never fully been explained. The Sahara Desert covers roughly 3.6 million square miles across 11 countries. It is the largest hot desert on Earth, a place most people picture as an endless, lifeless ocean of orange dunes. But that picture is wrong, and the further scientists look beneath its surface, the more that assumption unravels. James McDivitt and Edward White were aboard Gemini 4 when they spotted the structure. From orbit, it was unmistakable. Concentric rings, almost perfectly circular, sitting in the middle of the Mauritanian desert like something carved with intention. The outer ring stretches roughly 165 miles across. The central formation, the so-called pupil, measures nearly 25 miles in diameter. The entire feature covers more area than the state of Connecticut. It's called the Richat structure, and for decades, the leading theory was simple: a meteor impact, a rock from space massive enough to leave a scar visible from orbit. But that explanation didn't survive scientific scrutiny. No impact debris, no shocked quartz, no evidence of the catastrophic energy release that a collision of that scale would leave behind. Geologists eventually concluded it formed through a process called differential erosion. Ancient volcanic rock, uplifted over millions of years, worn down at different rates by wind and water, exposing those concentric rings like layers of an onion sliced open. That's the scientific answer. But it's not the only story attached to this place. Ancient Greek historian Herodotus, writing around 450 BCE, described a lost civilization to the west of Africa, a sophisticated seafaring society built in a series of concentric rings, each connected by waterways sitting near the Atlantic. He called it Atlantis. 2,000 years later, Roman geographer Pomponius Mela produced a world map that placed a city called Atlantia in the northwest African region. When both maps are oriented and compared against modern geography, the coordinates align, not with the ocean floor of the Atlantic, but with the Sahara, with the Richat structure specifically. This is where the story gets complicated. No excavation of the Richat structure has uncovered physical evidence of a human civilization. No foundations, no artifacts, no remnants of the canals Plato described. But the structural similarity between the Richat rings and the city layout Plato recorded in his dialogues is precise enough that researchers continue to take it seriously. The resemblance may be coincidence, or it may be that 12,000 years ago, when this region looked nothing like it does today, something was built here that time and sand have erased completely. Because the Sahara was not always a desert. That fact alone reshapes everything. Around 11,000 years ago, as the last ice age ended, the Sahara entered what climatologists call the African humid period. The jet stream shifted, monsoon rains pushed northward, and the landscape transformed. Lakes appeared, some larger than any freshwater body that exists on Earth today. Rivers ran for hundreds of miles. Grasslands spread across what is now one of the most hostile terrains on the planet. Hippopotamuses swam in waters that now lie beneath sand. Elephants, giraffes, crocodiles, the full ecology of sub-Saharan Africa existed here, in the middle of what we now call the Sahara. Human communities followed, and we know this not from written records, but from the walls of caves. In the Ennedi Plateau of Chad, deep inside rock shelters that provided shade and water to ancient travelers, paintings cover the stone. Cattle, swimmers, hunters. Entire scenes of domestic life rendered in ochre and charcoal by hands that touched this wall thousands of years ago. These weren't nomads barely surviving. These were people with livestock, with social structure, with enough stability to produce art. The cattle in these paintings are significant. Cattle require grass. Grass requires rain. The presence of these animals here is evidence of an ecosystem that modern satellite imagery would make unrecognizable. Then, around 3,500 BCE, the rains retreated. It happened gradually, then irreversibly. The orbital tilt of Earth shifted slightly, reducing the solar energy reaching the northern hemisphere during summer. The monsoons pulled back south. Vegetation died. Without vegetation, the ground reflected more heat, which suppressed rainfall further. The system fed on itself. Within a few thousand years, the lakes dried. The rivers shrank to threads, and the communities that had flourished here were pushed toward the only reliable water source that remained, the Nile. That forced migration likely accelerated the development of Egyptian civilization. The people of the Green Sahara brought with them agricultural knowledge, animal husbandry, social organization. The Nile Valley absorbed them, and the civilization that built the pyramids may owe something, perhaps a great deal, to the one that the desert swallowed. The Nile itself carries a kind of memory of that older, wetter world. At 4,130 miles, it is the longest river on Earth, cutting north through the Sahara from Central Africa to the Mediterranean. For thousands of years, its source was unknown. Ancient Egyptians considered it sacred, a river that began nowhere, fed by gods. Modern expeditions in the 19th and 20th centuries followed it upstream, through swamps and highlands before finally tracing it to Lake Victoria in Uganda. The river that sustained one of history's greatest civilizations originates deep in the continent that civilization left behind. Beneath the Egyptian desert, a different kind of mystery waits. The White Desert of Farafra is one of the most visually arresting landscapes on Earth. Chalk-white rock formations rising from pale sand, sculpted by wind into shapes that seem almost deliberate. This region was once the floor of the Tethys Sea, an ancient ocean that covered much of what is now North Africa and southern Europe. As tectonic plates shifted and that ocean receded, it left behind compressed layers of limestone and chalk. Wind erosion over millions of years carved what remains. Standing in it, knowing what it once was, the ground beneath your feet is the bottom of a vanished ocean. A gold pendant found in the tomb of Tutankhamun held a carved scarab beetle made of pale yellow glass. For decades, researchers struggled to explain what it was. The glass was unlike anything manufactured in ancient Egypt. Chemical analysis eventually traced its origin to the Libyan desert, specifically to a field of natural glass scattered across the sand. The leading explanation is that roughly 28 million years ago, a meteorite or comet either impacted or airburst above the surface with enough energy to fuse the silica-rich sandstone into glass. A pharaoh wore a piece of it around his neck. The desert preserved it for 28 million years before a craftsman found it and decided it was worth setting in gold. At an isolated oasis in the Enedi region, a small population of Nile crocodiles survives. They have been there, isolated, for thousands of years, cut off from the broader crocodile population of sub-Saharan Africa as the Sahara dried around them. They are smaller than their Nile cousins, subsisting on fish and frogs in a shrinking pool of water. They are a living remnant of the humid period, stranded by climate change, surviving in a habitat that grows more marginal each decade. Every year, approximately 182 million tons of dust from the Sahara lifts into the atmosphere and travels west across the Atlantic Ocean. A significant portion of it falls over the Amazon basin in South America. This is not incidental. The Amazon soils are ancient and heavily leached by rainfall. They are naturally low in phosphorus, a critical nutrient for plant growth. The Saharan dust carries phosphorus. Scientists have calculated that the dust delivered annually from the Sahara contains roughly the same amount of phosphorus the Amazon loses each year through river runoff. The Sahara, the world's largest hot desert, is fertilizing the world's largest rainforest. Two of Earth's most extreme environments, separated by an ocean, locked in a relationship that sustains both. The Sahara is expanding, roughly 10% per century along its southern boundary, a process called desertification, driven by a combination of climate change, overgrazing, and disrupted rainfall patterns. Communities that have lived on its edge for generations are being displaced. Agricultural land is becoming sand. This is not a slow geological process happening beyond human timescales. It is measurable within a single lifetime. And yet the desert's history suggests that this is not necessarily permanent. The Sahara has been green before. The orbital mechanics that drove the African humid period will, on geological timescales, cycle again. The monsoons will shift north. The lakes will return. Whether that happens in 1,000 years or 20,000 is beyond any model's precision. What the Sahara reveals, more than anything, is the fragility of the assumptions we make about landscape and permanence. The largest desert on Earth was, not long ago in geological terms, a grassland full of rivers and people. An astronaut looked down from space and saw something in its center that science still hasn't fully accounted for. A pharaoh's necklace contained glass formed by an event 28 million years in the past. And beneath the sand, scattered across a territory larger than the continental United States, the evidence of everything that came before continues to surface, slowly, grain by grain, whenever the wind decides to move. The desert doesn't erase history, it stores it.